Good morning, all you Precalculus students. Hope you had a great Easter holiday. I didn't post the video because I wanted to give you guys a break over the weekend. And I didn't check to see how many tried doing the lessons, but you didn't have to. So here we go. Are you excited? A new chapter. And this could be the last chapter we get done. Applications of trigonometry. So we've learned a lot of trig, a lot of identities. But now this lesson is basically the heart of the chapter. It's why we use those things and those formulas. It gives us the real applications of the real world. First lesson is a law of sines. Now, what is really cool about law of sines is if you have a triangle, now I'll put two triangles, one that we pretty much know would be a right triangle. So I'll put a 90-degree angle there. I'll make this 30 degrees and I'll make this 60. The law of sines says that the relationship between the angles and the sides do exist. That if I call this side A and this side B and this side C, the relationship will be that the sine of any angle I choose to use, I'll use the sine of 60, is related to the side across from it, B. Well, at the same time, I could say the sine of the 30 degrees is related to the sine across the 30, A. Well, you shouldn't be surprised that the sine of 90 degrees would be related to the side across from 90, C. Now, the interesting thing about those ratios is that you can write them as proportions because their relationship will be consistent with each other. So sine of, let me change it to sine of 60 over B is equal to sine of 30 degrees over A, which is equal to sine of 90 degrees over C. That's the law of sines. Now, we don't usually use all three together. We usually use two. And then hopefully one of those sides is already known. If not, in this particular problem, one side has to be known, or else you can't find the other two sides anyway. But if you had one side, you're good to go because you could, if you had side B, then you know the cosine. If you had B, the cosine of 30 degrees would be the adjacent, which I already know, over that I don't know the hypotenuse. But if you already know this side, you already know what the cosine of 30 is, square root of 3 over 2. So we're good to go. So you'll never have, in this particular proportion, you'll never have everything unknown. You have to have at least, everything should be known except for one thing you're looking for. That's just a right triangle. But the beautiful thing about law of sines, doesn't have to be right. It doesn't have to be right. If this was 22 degrees and this was 80 degrees, and that would make 80 plus 22 is 102. Then 180 minus 102 would be how much? 78? Because all three sides have to add up to 180. Hopefully they do. Okay, so it works on here as well. If I have all my angles, A, B, C, doesn't really matter. The sine of this 20 over the side across it would be equal to the sine of this 78 over what's across it. And if I chose I needed another one, sine of the 80 over the B. Now, granted, you have to know one of those sides, because even if I grab these two, I can figure out this with my calculator, I can figure out this with my calculator, I still would have two unknowns. So in a nutshell, that's what law of sines is. Now, in geometry class, you've learned about some congruence axioms. That if two sides and the included angle, that would mean this angle here if you knew these two sides. Of one triangle, there's one triangle, are equal respectively to two sides and the included angle of a second triangle. So I need a second triangle out here. And we said that the two sides are equal. So I have an A and a B. They're the same. And they have an angle. I'll call that theta 2. Well, actually, the angles are the same too. So it's just same theta. So look at it in geometry. That was side, angle, side, second triangle. That side was equal to that side. That angle is equal to that angle. That side is angle. Side, angle, side. That means these two triangles are congruent. Another good one for congruence was angle, side, angle. So angle, side, angle has an angle, theta, has a side, then there's another angle. I'll call that theta 2. If two angles and one included side, there's my included, it's in between those two angles, are equal respectively to two angles and the included side of a second triangle. So I have a second triangle with theta and a theta 2 and the included side, and they're identical. Angle, side, angle. We can say those two triangles are congruent. Congruent means they're the same shape and the same size. And if you think about it, especially for angle, side, angle, obviously they're the same triangle, because if these two angles are the same, then the opposite sides will be the same as well. It just would have to be, because it's a proportion, a ratio, I should say. Side, side, side. That would be, just as the picture said, A, B, and C. And we're looking at another triangle, A, B, and C. Yeah, I should make it more realistic. A, B, C. If three sides of one triangle are equal, A is equal to A, and B is equal to B, and C is equal to C, to three sides of a second triangle, then the triangles are congruent. If you have the same three sides, you can only make one triangle with it. Those three sides have to meet. So you can only make one triangle, so therefore the other triangle would also be congruent. And we call that side, side, side. We love side, side, side. It always proves congruence. Do you remember your definition of an oblique triangle? Oblique, a triangle that is not a right triangle. Every triangle that is not right is oblique. Now, most likely, you understand what an acute triangle is. An acute triangle just means that, or an acute angle, I should say. You could have 60 degrees, 60 degrees, and 60 degrees. All those angles are acute. Obviously, that's not a right triangle. If you have an angle that is bigger than 90, we'll call this 100, and maybe this is 45. No, I mean 40, 40 and 40. That'd be an obtuse triangle. This is an acute triangle. This is a right triangle. So obviously these two are considered oblique because they're not right. Now, the thing about an oblique triangle, the measures of the three sides and the three angles of a triangle can be found if at least one side and any other two measurements are known. Well, you already know that you could do the same thing if you had a right triangle and at least one side and any other two measures are known. If that was 30 and we had two other measures like 3 and a 4, you might be able to find that missing side. Okay, since we're solving oblique triangles, which is everything but right, because right triangles are easy to solve. Oblique or not, because you don't have Pythagorean theorem that works for oblique necessarily. You're not guaranteed a 90-degree angle. So you can't do a right triangle Pythagorean theorem. Here are your 4 cases that can come up. Side angle, angle, or angle, side angle. What does that mean in English? You have a triangle, any triangle, and we're going to say that we know how long a side is. So I'll just say side A. We know that. Then we know the next 2 angles as I go around the circle. I know angle theta, and I know angle beta. That's called, I know the side, I know the next angle, and the next angle. Side, angle, angle. Or, I have a triangle, and I know an angle. I will call it theta. I know the side next to it. I'll call B. Then I know the next angle. I'll call delta. It's a triangle. delta. So that's an angle, side, angle, angle, side, angle. What if you have a triangle where we know the angle that's included between two sides? That could happen. What does that mean? It means I have a side, and I have a side that is next to it, either left or right, another side. Then after that side, I happen to know theta. Well, that triangle is noted as side, side, angle. He's not your friend because if you ever get side, side, angle, this case may have more than one triangle, and you have to find them both. If you have two sides and the included angle, that would be like, I know this angle, and I also know the two sides that surround it. That's known as side, angle, side of that triangle. And then the last case is you could have an angle or a triangle, and all you know is the sides, A, B, C. You know those sides. Each of these have their own situations that come up. So we're going to explore a couple. Here, I don't see three angles on there. If we know the three angles, oh yeah, see that didn't come up, did it? I go back. If I knew the three angles, angle theta or alpha, angle beta, and theta. If you knew those, that's called angle, angle, angle. It's good for nothing to solve that triangle. Here's why. I could have the same three angles with a smaller triangle. This could still be the same beta, same theta, same alpha. But the sides, you could never ever figure out what the sides are because I could have the exact same angles, alpha, theta, and beta. But yet the sides of the original was A and B and C, and then this one was D and E and F, and now I'm at J and K and L. The sides constantly change. So just because you know three angles, it doesn't tell you about any information about the sides. So you can't use it to solve the triangle. When I use solve the triangle, it means find all the missing pieces. Was I going to do all the work of derivation? I'm not going to derive it for you. Basically, what he's going to do for you is you, you start out with a triangle ABC, and he drew the height, calling it H. Okay. And he said that's the length of the perpendicular vertex B to the side AC. That's called the height. The C in this triangle, the small c in this triangle ABD, he created an angle that was greater than 90, drew that height out here, and what he's doing is basically causing you to create another right triangle out of this obtuse triangle. I don't think I'm going to go into any more of the distance, but when he did that, he wanted you to see that in the original triangle, when you cut this height here, ADB, since that's a right angle, we know that the sine of A, that's this angle here, this is angle A, is equal to the opposite over hypotenuse, h over c. Solving it for h, because that's what we don't know, maybe we don't know h. H is c sine of A. If you go down here to the second triangle where he drew that height, and he drew it on the outside of this obtuse triangle, made that a right angle. Now we have side C, and we have an angle C, so sine of C now is opposite h over its hypotenuse. Ironically, you can solve that for h as well. H is a sine of C. Well, if they're both the same h's, then what he's telling you is you can set them equal to each other. C sine of A must be equal to A sine of C. And magically, what we have is, does this look familiar? If I divide both sides by C, sine of A equals A sine of C over C. Now divide both sides by A. I get sine of A over A equals sine of C over C. That's the law of sines that I already talked to you about. That is a derivation that you won't have to ever do, but this you will have to know. He does it again, and no, it's the same answer. He just shows you that you could recreate it and do A over sine of A equals B. Notice it doesn't matter which one's on top. You can switch that around. Sine of C over C equals sine of A over A. It's the same thing. Enough playing around. There's your law of sines. And again, I get used to doing it with my trig function on top. Sine of A over A is equal to sine of B over B. Sine of C over C. Have you noticed that the angle A is capital and the side A is small? And they're both A's, so they're opposite each other. This would be angle A, and this would be side A. This would be angle B, and this would be side B. Angle C, side C. Let's solve our first triangle. When we use the word solve, solve means find all missing parts. So I'm over here, and it looks like he's given me an angle, another angle, and he's giving me a side. Angle. He did not give me this one. He did not give it to me. Angle. Next to that angle, he did not give me another angle. Well, I have that angle. He gave me the side. So that looks to me like angle, angle, side. Or reverse it, side, angle, angle. So are those numbers the same? There's a side, there's angle A. There's side C, 81.8. Angle C, I'm sorry, it's a degrees. He gave me angle C. I think he messed up. That's not angle C. That's angle B. He made a mistake. I see his picture, 8.8. Besides, if I put that angle up there, that still would have worked. It's still angle, angle. It'd have been that angle, that side. It's still the same process. So It really doesn't change the answer at all. It's just the lettering is, he labeled that as, it's angle B. So I'm going to use it as B. You're going to find out it works out the same values. And side A, that would be this, yeah, that would be this side right here, 42.9. So to do it, realize a good combination I have. Do you have any A's together and any B's together, any C's together? Well, I have an A and an A together. So it would be nice to do sine of A over A. Now, since I put sine on top, I need sine on top again. So what angle do I know, or what angle do I have besides A? Well, I have, in this case, I'm calling it B. Sine of B I have, which means I'll be able to solve this for B that I don't have. I don't have B. See, that's this one right here. 1, 2, 3 things I have. Sine of 32 degrees over 42.9 has to be equal to sine of 81.8 degrees over what I don't know. Use your friend, the cross multiply and divide. Looks like this. B sine of 32 degrees has to be equal to the 42.9 centimeters times sine of 81.8. degrees. Why did I say cross multiply and divide? Because I don't know B. So B is 42.9 times sine of 81.8 degrees, all divided by sine of 32 degrees. And you should pause this right now, pick up your calculator, make sure you're in degree mode, because who knows what we did last on it, and key it in, and I'm going to do it, and I'm going to come back to you. Okay, B is approximately 81.1 unit with centimeters, if I did my calculator right. That's with 1 decimal place. The reason I'm using 1 decimal is because he had 1 decimal here. And he had 1 decimal of precision here. 1 decimal of precision here. So if all his precision was 1, then I feel free to do 1 decimal place. Let's see if I'm right. Problem, because we're not done. Because we have B. So we had 2 angles, and I just got this side. What else am I missing? I'm missing side C. So watch this. I have angle C, do I not? I don't see angle C. Let me erase my mess. Maybe it's there, I just don't see it. No, even in the writing, he didn't give me angle C. No, I don't have it. So I have 2 things unknown. Bummer. Because what if I put sine of C over C equals to, well, let me do the sine of A over A again. I know these two. I didn't know C or sine of C, because I don't know the angle. Oh my goodness, don't fear. That was the easiest thing to find. 1, 2, 3 angles have to add up to 180. So angle C will be 180 degrees minus the 81.8 minus the 32. So that's 180 degrees minus, because we got to find every part. So 80, 90, 100, 110, 111. I better do that again. 80, 90, 100, 110, 12, 113.8. I'm hoping the answer will be a 0.2, and that rounds it up to 14. Go ahead and use your calculator. I'll wait for you to come back. 66.2 degrees, according to my calculator. So great. We have angle C. So we found B. We found angle C. I'm still using approximate because we were rounding. What did I say? 66.2. Okay, now I'm missing. And we already had the other one. So, technically what you would do is you would say, here's angle A, here's angle B, here's angle C, here's A, here's B, here's C. And if you look at, we had 32 was A, 0.0. Let me do that. And angle B was 81.8. Angle C we just did 66.2. Side A was given to us as 42.9. What was the unit? Centimeters. Side B I just did. Oh, wait a minute. Oh, that's right. We reversed it. Side B is 42.9. And that meant because what did I say was wrong here? Oh, he called side C 81.8, but I changed it to that was the angle B was 81.8. Yeah, I fixed it up there. And just looking. That was angle. 42.9 was side A, not side B. So side B was my 81.1. So I'm just missing side C now. So where was my law of sines at? Oh, up here. I was going to use this. So sinus C. Now, typically, this combination here, one of these should be from what was given. You don't want to, you try to stay away from using sides that you computed. So since A's were in there, that works out good for me. Sine of 32, sine of 32 degrees over the 42.9 degrees. That was given to me. Now I'm looking for side C. So I am stuck having to use sine of C over C. So sine of C, what did we say C was? Somewhere in here. 66.2. Sine of 66.2 degrees over what I don't know. Now, can you look ahead and see how that's going to work out when you cross multiply and divide? Obviously, these two get multiplied together. And then we're going to divide by this one right here. So C will be sine of 66.2 degrees times 42.9. What did I put here? I put a degree sign? What am I, brain damaged? Centimeters. I don't know what I did there. Centimeters. Sinus is 42.9 centimeters divided by sine of 32.0 degrees. Again, calculator problem. Can't do those in my head. So pause it, pick up your calculator, do it yourself. Don't be lazy. 74.1 centimeters. 74.1 centimeters. There is your triangle solved. Oh, I have a blank here because there's more to do. I just want to make sure I finish up. Did I go too far? There's B, 80.1. Good. Did you get it right? Let's go back. Okay. Did he make a nice? This one's right. Oh, part. Let's see. There's that. There's that. Whenever possible, use the given values in solving. That's what I said a minute ago, rather than values obtained in measurements. The reason is when you obtain those measurements, we rounded them. They were all approximate. The only ones that were exact probably were the ones they gave me. Okay, example 2. He wants us to use an angle side angle. He's telling us up front. Word problem. Kurt Daniels wishes to measure the distance across the Gasconde River. Gasconde River. So there he is. He wants this distance here. He determines that C, angle C, so he's probably standing over here, and he's using some sort of protractor or a surveyor tool to figure out that, what did he measure across? That was 112 point, I'm sorry, wrong angle. Angle C. Down here, he measures that to be the 112. So he's standing on the other side of the river. And he's looking at somebody standing over here. So he has to have a point of reference. He measures that angle to be this obtuse angle. A, the distance of A, which would have been that's angle A. We're looking for the distance of A. Angle A, that's the smaller one up here. Once he figured out this, he goes and he measures looking at the point across the river. So he measures that one to be a 31.10 degrees. He's using 2 decimals. I noticed here. Here he only used 1. Here he used 2. I'd probably stick with 2 decimals. Side B, which is the easiest side to measure between himself and his friend, is 347.6 feet. We're going to look for this distance here. Now, the easiest thing to do will be to find that missing angle. We already have two angles. We have angle A was 31.10 degrees. We have angle C, which is 112.9 degrees. So we may as well find angle B. So that's going to be 180 minus both of those. 180 minus 31.10 minus 112.90. Finish it up. 180 minus those two add up to give me 143, 144, I think. 180 minus 144 will be 36 degrees with no decimal. Double check it with a calculator. My calculator said it's right. And since those have two decimals, let me go 0, 0. That shows precision to two places. Now, what do we know about side? Side A, we were given to us. Were we? No, side A is what we're looking for. That's the distance across the river. Side C. Was I given side C? Side B. That's the one we were given. 347.6 feet. So we have two measurements to find. Okay? So the first thing I want you to notice is that the pair that I have that goes together would be the B's. So I'm going to use those both times for both finding side A and side C. Sine of 32.00 over 347.6 has to equal to, let's go ahead and, well, we're only looking for, actually, we're not solving the whole triangle. We just need this one. Sine of, that was 31.10 over that's the distance I want. That's the only one I wanted, was this one. Again, you know, these two get multiplied together. That's going to move up to the left. So we're going to divide by this one. So A will be sine of 31.10 degrees times 347.6, all divided by this piece here, sine of 32 degrees. And it is a calculator problem, so get your calculator out. I'll be right back. We find out that A is 305.5 feet. That's how far the river is. Without having to get your feet wet. Not too shabby. Let's see if we're right. That was right. He does it in reverse order, but we get the same feet. Wonderful. Example 3. 2 ranger stations. Okay, so we have ranger station A, ranger station B. They're on the east-west line. Get it? West, east, north, south. A forest fire is located on the bearing of north 42 degrees east. Do you remember what that was? That was from the western station. So here's the western station. So we go our bearing straight up north, okay? And then he says north 42 east. So you go east 42 degrees from the bearing of north, which is why you have that angle. Doesn't matter how high you go, it's still the same angle, 42 degrees. And then at station A, it's a bearing of, when you head north, it's 15 east. So when you're at this station, you're basically going to go east 15 degrees. So what he said? I'm sorry, I went the wrong way. That was west again. East is 15 degrees. So 15 degrees. To the nearest 10 miles, how far is the fire from the western station? The nearest 10 miles. So let me get rid of all my scribbling on it because I can make sure I see it. Well, there's that fire. We have our 42 degrees here. We have our, this is a 15 degrees here. So it makes it a weird triangle here. 15 degrees. That little bit's 15. I'm a little concerned because I don't have all my, do I have any angles there at all? Well, let's see here. We know this together makes a right angle. So 90 minus 42 would be 58. No, 48. Yes, 48. Because those two add up to 90. Now, this whole angle here, I'll call it angle B. This is 90. That's 15. So that would be 90 plus 15. And it makes sense that it's obtuse because look at it. It doesn't look like it's right. 90 plus 15 is 105. So that's 105 degrees. And as we did before, if you have two angles, this third one should be easy to do. That third one, C, or angle C, however you want to do it, is 180 degrees minus the 48 minus the 100 and, can't read my writing, 90, 105, that's what that was, minus 105. That's 180 degrees. They're both negative. So that's 48 plus 105 is 148 for 950, 153. And 180 minus 153 is 27 degrees. This little angle is 27 degrees. So I have everything I need. So what was the question? I forgot what we were asking. How far is this fire from the western? He's asking for side B. So you know I'm going to have sine of B over B in order to find side B. So is there a pair that I have? Do I have any other measurements? Well, I have this measurement. That would be side C. And I have angle C. So I'm going to use sine of angle C over C. So sine of B, that's sine of, my B angle was 105 degrees over B, which is what I don't know, equals to sine of C, which is sine of 27 degrees, over C, which was 110 miles. So again, these two get multiplied together, and obviously I divide by the third one. So B should be sine of 105 degrees times 110 divided by the sine of 27 degrees. So B will be approximately, and you round it to the nearest 10 miles. I'm going to go use my calculator and use yours. Okay, I got rounding it to 230 miles. So let's check it. Yep, I found that angle. Actually, I did all that work. There it is. Sweet. All right, now, ambiguous case. Ambiguous means that you could have more than one answer. Remember earlier in my notes, we said that if we had this bad word, side angle, SSA, that you could have two answers. Now, you could have two, but it still could be one, or it could be zero. It may not work at all. At most is two, as few as zero. See why this would be the case. If you had side angle, so you have this, let's see. Okay, looking at his picture here. If B is an angle along this side, so somewhere there's another angle, and it could be like this, it could be like this, could be like this, if a triangle exists. But think about it. This angle could be different angles. You're only guaranteed knowing one angle. Okay, the chart shows that if A is an acute angle, you have four outcomes on this. Can you see how this picture would show zero triangles existing? If side B was it looks to me like side B would have to be the biggest side. Biggest side is bigger than A or bigger than C. This is side C, and side A is smaller than both of those. Well, if you have A and it's locked, and you have a measurement for side A and it's smaller than B or C, notice this side, that angle's locked as well, because these three angles have to be adding up to 180. So this angle is locked, but the side's not long enough to get to the bottom. So that triangle can't exist. The perfect, if it's acute, would be if the angle B was 90. Then you know that side B would have to be the longest side. Side B is the longest side. And A would equal to B. No, it can't be equal to the H. It's the hypotenuse, not the hypotenuse. It was the height of the triangle. It's the height of the triangle. And A in this case has to be less than B because the hypotenuse is the longest. So you only get one triangle. It's a right triangle. If it works out beautiful like this. Now, if you had the two measurements, again, you have side C being the longest, and A is also longer than B, which would make sense. This angle's locked in place, so you're going to get this measurement out. It has to extend both those legs that way. Side A, if it connects beautifully, that's why you get one solution. There's only one way it can go. This is if your side A is less than B. Bigger. Side A was bigger than B. Up here we had side A was smaller than B, and it just didn't work. You can get no triangle. Now, the last case is the height of the triangle is less than A, and it's also less than B, the height of the triangle. This angle is still locked in place, so these two legs are still here. But what happens is there's actually two triangles that can be made, because this leg could go down here, or this leg could go down here, and you have a longer side. Because the side wasn't locked in place, just the angle. And we're still talking about the angle side. So angle B and A, they're locked. This side was not locked. B and A are locked, angle A is locked. That's where we get side angle. So you have two possible triangles. What if it's an obtuse triangle? We're still talking about side angle, side angle. So we still have two sides, A and a B, and a locked angle. And if it's obtuse and A is going to be smaller than B, you can't make a triangle again. It's not long enough. A has to be longer than this B in order to reach to this side here. So that's why there's none, if it's obtuse. Now, if A is allowed to be longer than B, then you could stretch it out to get to the side. Because remember, angle A is locked, side B is locked, and side A is locked. These measurements are locked. This would form a triangle, but only one triangle. For any angle of a triangle where sine of theta is between 0 and 1, if sine of theta is 1, well, that meant you have a 90-degree triangle. It's a right triangle. If sine of theta equals sine of 180 minus theta, well, what does that imply? If they're both the same, that means they were supplementary of each other. If they're both the same. I mean, sine of theta, 180 minus theta, they add together to become 180. That'd be like sine of 10 and sine of 170. The smallest angle is opposite the shortest side. That's probably one of the most important things that you should know. The longest angle must always be across from the longest side. Obviously, the middle would be opposite of the middle angle. Though that's just, to me, that's probably the most important thing he wrote on that slide. All right, now the fun begins. Now, we're dealing with, he said there's no such triangle. At least he's telling us up front. We're going to see how no triangle can exist. Solve this triangle. I'm just going to make it up here. A, B, C. I'm just going to make up A, B, C. And he said B was 55. So let's put that right here, 55. Let me mark that with a different color. Side B is 8.94. 8.94. And side A is 25.1. Oh, so side A, so that's 25.1 meters. Okay. So to solve this means I would I would have to have, this is an angle, side, 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 side angle. This is the problem that you have the zero solution, one solution, or two. He's telling me up front, zero. Let's see, why is it zero? First of all, did you notice the angle he gave me is an acute? If he gave me an acute angle, this angle is locked. This side distance, this leg, in other words, this leg is locked, but this leg is not, well, is locked because I have this angle. So basically, those two legs are locked. Now I got to figure out, is this side long enough to have reached from end? Is it hanging, or is it looking like this and not long enough? I will work out. Let's see, the pair I had was the B pair, so I had to have this, a pair that had sine of B with B. And then I have this side here, which goes across from angle A, so it makes sense that that's the combination proportion I need to work on. Let's see what happens. Sine of, let me do black. Wrong shading. Sine of A, which is sine of, I labeled it, didn't I? No, I don't know. I don't know A. That's the whole thing. I don't know that angle. Sine of A. I know side of A is 25.1. The B combination, this is the one that I do know. Sine of 55.40 degrees over opposite of angle B was 8.94. So when I solve this, for the only thing I don't know is sine of A, sine of A will be the sine of 55.4. Oh, wait, that's not 0.4. I didn't even notice it. I wasn't paying attention. It's 40 minutes. I didn't even see that. 40 minutes. I mean, I got to key that in differently. I got to key that in as, remember, 55 plus 40 out of 60 degrees with my calculator. That's how I'm going to key that in. So 55 degrees and 40 minutes. 40 minutes. So we know how to key that in. 55 degrees, 40 minutes over 8.94 times the 25.1. All right, so go to your calculator, key in sine of 55 plus 40 divided by 60, put that in parentheses, times 25.1, hit the enter, divide by the 8.94, and we're going to find out what sine of A, what decimal number it gives me. I'll be right back. I'm back. Calculator says 2.3184. 3184? I can't remember. Now, it doesn't really matter because, go ahead, I dare you. I dare you. Do the arc sine of both sides. I dare you. Arc sine of 2.3184. That's how you get the angle out of it. When sine of A, we have to do the inverse, remember? But that should give you an error. Why? Sine of any angle has to be less than or equal to 1, greater than or equal to 0. It can't be higher than 1. So that told me a big fact, that angle A, this angle here cannot exist with those two measurements. Okay? That means that is either too long or too short. Either way, it's not gonna work because this angle is locked. Who knows what's going on? It could look like this. That's just way too long, or it could be way too short. Either way, it doesn't exist. Well, that wasn't too bad. There you go. All right, example 4. What about, again, with no such triangle? Oh, no, he's trying to draw the sketch. There was angle B, side A, side B, 8.94 was just too short. Too short, could not reach it over here. In the ambiguous case, we are given two sides and an angle opposite one of the other sides. There's your SSA. This time, we're going to have two possible answers. Let's see how that works out. Let me draw my picture again. A, B, C. Angle A, he went back to using decimals. 35.3 degrees. 35.3 degrees. Side A, that goes together, 22.8. Side B, over here, 24.9 feet. What measurements do I not have? I don't have side C. I don't have angle C. I don't have angle B. What do I have? I have an angle. Next to it, it's side. And then I have its side. Or side, side, angle. So that means I have to be prepared for three cases, 0, 1, or 2. And he's already telling me a hint. There's going to be 2. So he's helping me out. So the pair that I have for sure are my A sides. So for sure I'm going to do sine of A over A. And since I have side B, I'm going to use it, meaning I don't have sine of B. So that's the proportion I'm going to use. Sine of 55.3 degrees over 22.8 will have to be what I don't know about sine of B over 24.9. Set that up. These two go together, divide by the third. Sine of B will equal to sine of 55.3 degrees times 24.9. And I'm dividing by the 22.8. Work that out and come back and tell me what sine of B could be. I'm going to use my calculator. Use yours. I hope you got something like I got. 0.89876. Let me go look at my calculator again. I already forgot. 89786. I'm dyslexic. So then we got to do the arc sine, both sides, remember? That didn't go away just because, to get rid of the sine, I do the arc sine both sides, arc sine both sides. That gives me B is, and we're in degree mode because that angle A was in degrees. So now go second sine of your last answer. Just do second sine of your last answer. Second enter to get your last answer. I'll be back. 63, I'm going to round it to 1 decimal place, degrees, 0.9. Because he had 1 decimal place right here. 35.3, that was 35.3, 1 decimal. All right. Now, that's a good answer. But remember on my unit circle, if there's my angle B, and it is 63.9 degrees, and it's positive, well, where else is my angle positive? In quadrant 2. That could also be a 63.9 degrees over there. But it's not, we don't call it 63.9, that's its reference angle. One of my B's is 60.9. The other angle B could be 180 degrees minus 63.9 degrees. So that becomes, let's see, 180 minus 60 is 120, but I still have to take away 3.9, so 116.1. Let's see, 160, I don't know if that's right. 160, 170, 176, 9. I think so. 116.1. I'll use my calculator to make sure. Okay, it's correct. Now the question might be, does this triangle exist? Can that angle be 116? Let me look up here. First of all, if B was 63, let's look at that answer first. If B was 63.9, if that's true, could angle C exist? Well, surely it could, because 63.9 plus 35.3, 35.3. Whoop, I wrote it wrong. Was 53. Did I write? I used it 50. Okay, good. I got scared. Thought I did it all wrong. 53 point, I was dyslexic again. 55.3. So if I had 63.9 and 55.3, 12, 9, 11. That would force angle C to be 119.2 degrees, which is nothing wrong with that. That means it would work. If I choose to use the supplement, the 116.1, notice how the triangle changes. This becomes 116.1. This still was 55.3. Let's add those together. 55.3 plus 116.1. That's 2, that's 0.3, 6, that's 11, 7, 170 1.3 degrees. Well, that's also true. That leaves a very small angle here. Angle C would be now 180 minus 171.3, which would be 8.7. Both legal triangles. So that's why this was an ambiguous case. Now, so what happens is you check that supplement, and then you got to make sure that it does work in both triangles if that was the case. You can see how this is the hardest of all the problems we've done. And we're really not out of the water yet, because even though I believe both triangles exist, we still have to solve both triangles. So what I have to do now is, let's see, we got two triangles. The first triangle we had, let me fill everything in that we already knew. 55.3 was my angle, I'll put it over here, it was angle A. And we knew that small a side would have been 22.8 feet. We knew that side B was 24.9 feet. And those were the three measurements they gave. And we solved it the first time, and we've got a 63.9 degree for B. So let me add that. We found 63.9 degrees. So what was left to finish solving this? Well, we had B, we have A, I don't have C. So that's going to be made up of 180 degrees minus the other two sides that I found that are probable, 55.3 degrees and 63.9 degrees. That's 180 degrees minus, did I do my calculator or my head? I make mistakes in my head all the time. 9, 10, 11, 12. Carry the 1. 5, 6, 7, 8, 9. No, I messed up again. 5, 6, 8. No, it's fine. And then 11. 119.2 degrees, giving me a total of, I already did this math. I think I did it over here. Well, there's that. I did it over here. But I have to do finish it up, figure out what angle C is. So that's 180.0. So I know I'm going to have a 0.8. And that gave me 179, 60. 60.8 degrees is C. And then for the sides, well, we know A was given, B was given. I still need C, side C. So how will I do side C? You're stuck doing law of sines again. Let's see here. The pair that I had was sine of A over A equals, now I have to use the sine of C. Good thing I found it, over C, which is what I'm looking for. So that's sine of A was sine of 55.3 degrees over A, which was given to me, is 22.8 feet. 22.8 feet. Sine of C, using the angle that I just discovered, was 60.8 degrees over the C. Long story short, move the C over, move the 22.8 over. C is equal to sine of 60.8 degrees over 22, I'm sorry, times 22.8 over the sine of 22. No, I do that again. Sine of 55.3. 55.3 degrees. All right, so go ahead, get that in your calculator, and let's compare in about 30 seconds, and we'll see who's quicker, me or you. Did you get 24.2 rounding it feet? That would be one of your triangles. Remember, we had another possible triangle. The given's the same. We were given angle A was 55.3. We were given side A is 22.8 feet, I believe. Third thing given to me was side B was 24.9. That was B, 24.9 feet. So again, we had angle A. That was 55.3 degrees. We found angle B, I believe over here. The other B was 116.1 degrees. So we found this one to be 116.1 degrees. So now we got to see what would C be. Well, C would been 180 minus 116.1 degrees minus 55.3 degrees would be measure of angle C. So 180 degrees minus, let's see, that adds up to 4. And 6 plus 5 is 11. That's 2 is 7. 171.8, which would come out to 8.6 degrees. Let me double check it with my calculator. Yep, calculator says 8.6. So now 8.6 degrees. Angle or side A was given 22.8 feet. Side B was given 24.9 feet. C, again, I don't have, so it's a law of sines again. So I'm going to stay true. Sine of A over A, because that was a given pair. Then I'll have to use my sine of B, my newly computed B, over... No, what am I doing that for? I need C. I already had the B. Sine of B, using the newly computed B, I get the 8.6 over C. That's what I'm looking for. Here goes again. Sine of 55.3 degrees, 22.8 feet, equals to sine of 8.6 degrees over C. I'm getting kind of tired of this problem because I thought it was long enough to begin with. So cross multiply and divide. C is equal to sine of 8.6 degrees times 22.8 feet over sine of 55.3 degrees. Use your calculator and let's see what that side gives me now. I'll be right back. .15 feet. Hope you agreed with that answer. And since I've labeled, put that up there, 4.15. That's triangle solved. The other one was solved. Let's check our answers. See if some numbers stand out. That stands out. 24.2. Did I have that? That was that first triangle. Yep. Okay, there's my second. Yep, got it. Everything's fine. Wow. And he drew both pictures. Much better than mine. Because remember, I had that small angle of up here at a small angle. Over here it was bigger. So he didn't even label it. Can't remember how big that was. It was like 8 or something. Let's see, we can figure it out. 116.2 plus 55.3. That was 4. 9. 169.4. So small. 55. No, I've added wrong. 3, 4, 5. 55.3. That was a 1. That is a 4. I added wrong. 6 plus 5 is 11. 74. Okay, 174. It was very small. 180 minus that. Very small. Okay, so let sides A and B and angle A be given. Okay, this is just rehashing what we did, how we had no triangle that existed. That happened when the sine of B was bigger than 1, obviously, because we couldn't take the inverse sine, remember? And if sine of B was equal to 1, then we had the 1 triangle. If sine of B was between 0 and 1, you have the potential of the 2 triangles. Remember, we had the 1 triangle here and the 1 triangle here, which gives us this probability here. Things to keep in mind. He's going to show us the ambiguous case with 1 possible triangle, and you'll see why there's only going to be 1. Let me draw my A, B, and C. A, B, and C. What am I labeling? A was 43.5. And that's this one. Side A across from it, that must be my pair. 10.7 inches. Side C is 7.2 inches. So what am I missing? I'm missing side B. I'm missing angle C. And, oh wait, I don't have angle B either. So pick the pair that I have. The A combination. So sine of A over A can be worked with any of the other 2 pairs. If you want to find angle B and B, would this work? Sine of B over B? And the answer is no, because I don't know either of them. And that's too many unknowns. So go with a pair that has something, the C. Go with the C because then, let's see how that's going to work. Sine 43.5 degrees over 10.7 inches. Sine of C, I don't know that angle, but I know side C was 7.2. Set that up. Basically, sine of C will equal to the 7.2 going to the other side times the sine of 43.5 degrees divided by the 10.7. And hopefully your calculator will work. So be right back. Go to my calculator. I get 0.46319. That's the sine of the angle is that. That is between 0 and 1, negative 1 and 1, so it works okay. Plug it in, inverse sine. C must be, I'll come back, be right back. Rounding it, 27.6 degrees. Oh, I didn't even notice I had this decimal right here. I already had that there. 463.191. Okay, that's what I had on my calculator. Now, what's the deal with this? This angle is an acute angle. So it falls in this quadrant here, right? 27.6 degrees. Where else is sine positive? This is the same thing we had, the same problem we had before. It could be over here. And if this is 27.6 degrees, then this total angle would be 180 degrees minus 27.6 degrees. And do my math, that's about 152.4. Make sure these two add up to 180. Let's see, 6, 9, 10, 28, 30. Yeah, 152.4. So we say, okay, so my other possibility of C could be 152.4 degrees. But let's look at my triangle here. If I had the 27.6 as angle C, so let me put it in blue here, that this gave me C of 27.6. And if I'm solving this triangle, and I still need angle B, then it looks like it would work, because 43.5 plus 27.6 adds up to 40, 50, 60, 70, 71.1. So angle B would be 180 minus 71.1. So angle B would be 8.9, 108.9. 108.9 degrees. So now I got my angle B, and I got my angle C. So I got my angle A was given. Angle C, I just calculated it, and then I used the possibility of the 180 rule. So I got my angle B. That's perfectly fine. So let's look at triangle 2. I'll just redraw my picture here. I was given angle A, 43.5. I was given that side A was 10.7 inches. And what I just think I accomplished was that I found angle C as the supplement of the 27.6. That's 152. So I'm thinking that could be a 152 degree angle. 152.4 degrees. So now all I'm missing is what would angle B be in this case. Angle B would have to be the 180 degrees minus the other two angles. 180 degrees minus, add those two up, and what do you notice? If you add those up, 5 plus 4 is 9, and 43 plus 152, That's a 5. And 5 plus 4 is 9. 195 degrees, giving you a negative 15.9 degrees. Well, that makes no sense. You cannot have a negative angle in a triangle. So even though it looked like it was the other problem, by using them both, you find out that that second triangle doesn't exist. So that's why there's only one triangle. Let's see if he agrees. That looks familiar. That looks familiar. That looked familiar. Second one here. Okay, we're looking here. I don't see the problem yet. Oh, the 152.4 was not possible. He did it a different way to show it's not possible. But well, no, he just found that 108. Yeah. Okay. When using the law of signs, explain why A at 104 degrees and small a, the side, is 26.6.8, and small b cannot be valid for triangle ABC. Well, let's just look at it. A, B, C. 104 point. Well, he has nothing. 104 degrees. 26.8 meters. 31.3. Well, we're looking at an angle side. Now, it's jumping out at me. I'm not even doing any work. That's a big angle. It needs the biggest side. It definitely has to be bigger than this side. Because there's no way that angle C can be bigger than 104. Let's just pretend it's 105. Because that side's bigger. Bigger sides go with bigger angles. If that was 105, 105 plus 104 is 209 degrees. That's too much. Even if it tied it, well, it can't tie it because these sides aren't the same. It had to be a little bigger. That is so far above 180, it's just not possible. So I'm just going to write, if angle A is 104 degrees, side A needs to be larger than side C. Angle C cannot be greater than 104 degrees. Good enough. Let's see. So just the longest. Yeah, that's what he did. All right. Last little bit about how to find the area of a triangle. You are so used to these triangles you've got your nice measurements and you just can do your formula, 1/2 base times height. That works because the height is perpendicular to the base, always. And it's easy to find that distance because you have Pythagorean theorem. If you're given two sides, you can always find out. It just works out so nice. So that makes no sense that 1/2 times 6 times 2, which is 1/2 of 12, which is 6. Very easy to do. But what if your triangle was obtuse? Or what if they were acute? The chore becomes a little harder because then you have to figure out what that height is, what this height is. And the truth of the matter is, there's a general formula. Your geometry teacher did not teach you this, but the true formula really is 1/2 times the base times the height, but always talking about the angle in between those two sides. Sine of that angle, I'll call it in this case A, if it's in between this B and C. Well, in a right triangle, that turns out to be 1/2 times 6 times 2 times sine of 90. Sine of 90 is 1. It doesn't really affect anything. That could be why your geometry teacher did not teach you this formula, because this was irrelevant. The answer was still 6. But what if all you still had was 7 and 9 and I don't know what angle would work. I'm just making it up here. What if you did have that angle? Could you find out? Well, sure you could. I can give you any angle I suppose I want and make it fit. Let's give it, let me give it a 110 degree angle. So my area now would still be 1/2, but it's not base and height. It was base and height over here because it was a right triangle. But if it's not a right triangle, they're just two separate legs. They're just two separate legs. So what looks like it could have been a base, it's not really a base. What looked like it could have been a height, it's not really a height. But it's still the two sides that include that angle. It's the angle sandwich. Sine of 110 degrees. We'll find the answer. So in this case here, maybe this was a 60 degree angle. Maybe they're all 60s. Who knows? Could be. Could be 60, 50, and 70. It doesn't really matter. But if this was 10 and 12, doesn't really matter. They're locked. The angle's locked, the sides are locked. You can find a string that can attach here to here and you can measure it. But 1/2, and we call it A and B sine of theta, and A and B always stands for the included sides. 1/2 times 12 times 10 sine of 60. That's 1/2 of 120 sine of 60. That's 1/2 of 60. Sine of 60 is the square root of 3 over 2. So the final answer is 30 square roots of 3. And all these answers are square units. Square units. Unit squared. Unit squared. Square units. So there's your formula. Doesn't matter what letters you're using. Notice, whatever two letters I have, the angle is not one of them because the angle is in between those two sides. C is between A and B, the angle C. A, B, angle C, small c. So you don't have C in there because the big C is the angle that you're using. Okay. I gave that away already. Okay. So find the area of this triangle. And it's obviously a calculator problem because I don't know the sign of this problem. But I'm just going to write it out. Area is 1/2. Oh, AB. Sorry. I need to do my... It's actually in this case going to be A, C. 1/2 AC. Doesn't matter though. Sine of the included angle, B. Just know that it's 1/2 times each of the legs that includes the angle. 42 feet times 34 feet. And they are 0.0, so we have 1/10 accuracy. Sine of 55 degrees plus 10 minutes, which is 10 over 60. So let me take off that degrees. 55 plus 10 out of 60 degrees. Calculator problem. All right, you key it in. I'll make it easy though. 1/2 of 42 is 21 times 34 sine of this. And I'll give you a couple seconds. Pause it, get out your calculator, make sure you can do it. Uh, 586, since the measurements are always at 0.0. Oh no, well, I'll just leave it. There's no decimals in any of those except for that angle. Feet squared. That wasn't bad. .586 feet squared. Yeah. Find the area of this triangle. So angle, side, angle. If I want to find the area of this, I need an included angle. This is an included side. It doesn't help. What I need is to have either side A or side B. That way, if I had side C, then that's my A is my included angle. If I had side A, then side C would be my included angle. You just have to decide which of those do you want to find. Which side you need to have the angle sandwich. So the angle has to be the meat between the bread. Doesn't really matter. You have skills. You have something called the law of sines. Okay. So you got to decide which one you want to look for. I guess I will, since A is right here, let me just do this one. Let me find out what, let's see, sine of A over A, because when I'm going to look for A, I have sine of A, equals to, oh, I need another angle. Because I got my B here, sine of B over B, but I don't have an angle B, so I need another angle. That should be easy enough. Let's see. Angle B will be 180 minus 24 plus 40 out of 60 degrees minus 52 plus 40 out of 60 degrees. Okay, so that's a calculator problem. Obviously, I can't even do that in my head, so pause it, get your calculator out, see if you can beat me to it. $102 with a whole lot of sixes, right? that whole lot of 6s, 40 out of 60 is 4 out of 6, which is 2 out of 3. It's at 40 minutes. So I'm going to write that as 102 degrees and 40 minutes. Just because that's the way the notation is for the rest of it. So that's 102 with 40 minutes. Now that I have that, I can now use my sine of A over A, which was sine of 24 degrees and 40 minutes over with the side I'm looking for has to be equal to sine of B, which was sine of 102 degrees and 40 minutes over the B, which is 27.3 centimeters, 27.3. So A, if I solve crisscross multiply, A will be equal to sine of 24 degrees, 40 minutes, times 27.3 divided by sine of 102 degrees and 40 minutes. You know how to key that in the calculator. A will be, pause it, calculate it, see if you're right. And 11.7. I'll go 1 decimal place because he went 1 decimal place here. 11.7 centimeters. Okay, why did I need that? I'm trying to find the area. I needed the angle sandwich. So now I've got that side, and this angle here. So area is 1/2. In this case, the letters, not that it matters, would be A and B. It just happens to be AB. Sine of angle C. Sine of C. That's what it is. Okay. Plug everything in. 1/2 times 27.3 times my 11.7 times sine of 52 plus 40 out of 60 degrees. Key that in your calculator. I get 107.735 centimeters squared. And I've keyed it in twice. And everything looks fine. Fine. Getting ready to do it. 1/2, 11.7, 20.3 sine. Only problem is he's getting 127. So I am not sure. I'm going to look at my calculator one more time. Okay, I pasted my calculator screen. Make sure I'm keying it in right. 1/2, 11.7 times 27.3. 1/2, that's 0.5. I even did it with a 1/2 times 11.7 times 27.3. Sine of 52 and 40 minutes. That's it right here. I did it with the 40 out of 60. I did it with 0.666s. And each time I got the same answer, 107.735. So the only thing I can say is maybe he's wrong. 5240. Yeah, I think I'm right. I'm moving on. Hey, if you figured out what's wrong, extra credit. Let me know. Hit me up. Hit me up on Remind. that is the last problem. So you have a day to get this stuff done. And if you have any questions, just send them to me. If you need me to do, I can do a Zoom any day at 9 o'clock. And if people have some questions, we can work together. Just give me some advance notice. Bye, guys. Have a good one.